The Open Distribution System Simulator, OpenDSS, is a comprehensive, electrical system simulation tool for electric utility distribution systems. OpenDSS is an EPRI, open-source library that provides the possibility to develop external functionalities using the Common Object Module Interface (COM) through numerous programming languages, such as C# that is natively used in ActionNET. For integration with ActionNET, the Interop OpenDSS engine was developed. It contains all classes and methods of the native OpenDSS DLL, and we can implement the same example available in the OpenDSS manual directly in the SCADA Action NET. To use the DLL, just go to Run, Build, References, click Add DLL References, and search for the DLL in ActionNet directories. In the near future, SPIN will develop an application that will allow the customer, without knowing OpenDSS, to configure an electrical system model and execute an ADMS application with topological processor, state estimator, power flow, contingency analysis, control volt-var, etc. Before that, however, as shown in this example, you can use the OpenDSS library and reading the EPRI's documentation, available in website, deploy electrical applications with tall SCADA facilities of exchange data with the IEDs and generate HMI screens. In the presented example, a basic application composed of symbols, displays, and scripts containing the integration logics with OpenDSS library was developed. The reports used are directly pointed to reports of OpenDSS. The application now shown is based on a pulp factory called OR Cell. When the application is open, we can see in Run, Build, References that the Interop OpenDSS engine is already integrated in the SCADA Action NET. We go to Edit, Scripts, Tasks. We see that there are several C# tasks developed to implement OpenDSS application functionalities. We navigate to the C# code of one of these tasks, called Generate Files, and see that is a program written in C#. After, we do the same to another one, called Generate Master. When we run the program, initially, the user enters his code and password. The first thing we do is manually run the power flow, and a message is shown saying that the system has converged, that is, the electrical parameters of the system are coherent. Following, the click on the online button runs every 6 seconds the modules of topological processing, power flow, and state estimation. The OpenDSS library has templates for dozens of elements, such as circuits, lines, transformers, all kind of generator, loads, etc. In this application, as shown in the film, these elements were modeled. For each element, we entered with a set of parameters supplied by OR Cell itself, and the others were used, considering the parameters suggested by the EPRI library. The latter element presented is the Thevenin equivalent of the system. Following are commands to open and close circuit breakers of various circuits of the network, removing and inserting loads in the system, and we can observe that the application responds correctly to these actions. Finally, we go to the System Report area, and generate, online, several reports that are presented on the screen. These reports are the reports themselves made available in the OpenDSS library without any change. The last report presented, generated from clicking the Visualize button, available in each modeled element, shows the three-phase currents, voltages, and power of the element. Concluding this presentation, if any customer wants to do some testing or development using ActionNET with the OpenDSS library, please contact us, that we will be happy to make this optional version available.